Hi guys, in this tutorial we're going to make a very simple game using FXGL 0.3. This tutorial is also suitable for people who've never used FXGL before, so you can use this tutorial as a starting point. All you need to have is a Java project in your favorite IDE and have FXGL as an external dependency, either using it in a Jar form, or you can use Maven Gradle distribution in order to pull in the dependency on FXGL into your project. Once you've done so, you can create a package with any name. Currently I'm using shooter as the package name, and the idea for this game is going to be, again, very simple. We're going to have enemies that spawn at random locations after a certain period of time, and we're going to have bullets that we can control in order to destroy the enemies. And that will be it for the entirety of this game. And while building the game, we'll also learn about the new architecture in FXGL and how we're going to use and how this affects our FXGL game structure. So the first thing to do is to create a Java class called shooter app. This is going to be our main entry point. And by convention, you typically add app at the end of your project name to signify that this is going to be the main class of your game. Next thing to do is to extend game application and override its single method called init settings. So if you've used FXGL before, then you'll realize that we no longer need to override anything else, just initialize settings. You also might want to have a main method to run the application, in which we simply call launch with the arguments provided. The settings we're going to use is width, height, so these are the standard ones. We want the title to be shooter app. We want the version to be something like 0.1. We want to disable profiling and a few other things like close confirmation, menus, and intro. And that should be enough. So at this point, you can already start the game and see something like this. If you haven't run FXGL before, then there will be a dialog saying that there is a newer version available, and what you need to do is simply discard the dialog. It will pop up every 7 days by default, saying that there might be a newer version. And it will also say what the version, what your version is and what the newer version might be. Right, so we've done this part. And the next thing to do is to create types of entities that we're going to use. So we've said that we're going to have enemies and bullets. So we're going to create an enum, which will contain just two types, bullet and enemy. And depending on what kind of game you're developing, you're still going to have entity types. So by convention, or one of the things that we now call a convention, is to name the type as well with the project name. So you'll have shooter type to name the type of entities that you are going to have in the game. And finally, for the new architecture is to use a factory, which is going to be named, again, shooter and factory. Ideally, this is the only place where you can create new entities for your game. And to mark the class, we also implement entity factory. And this says to the developer that this class is where entities are created. So this is the first thing we're going to do now, after we've done all of these things. We're going to create a method that will spawn or create our bullet. So this is the new signature that we use for spawning methods. It has to be public. Also, it is not a static method. It returns type entity. The name could be anything. And the only parameter that it takes is spawn data. And that data object contains a map inside that allows you to add as many properties as you need in order to spawn this particular entity. At the very least, it will contain values x and y to say where to spawn the entity. We're going to use the entities class, which allows us to conveniently create entities. We'll call builder. So this is our bullet, and we want to spawn the bullet from this data. By default, this simply sets x and y position to the entity. We also want to set the type, which we already know, which is shooter type.bullet. Then we want to create a view from node with the bounding box, because we want the bullet to be able to collide with our enemy. So it has to have a bounding box. And we'll use one of the JavaFX shapes like a rectangle with 10 and height being 2. And perhaps color blue. Finally, we build, and that returns the created entity. What we also want to do is to mark this method that it spawns something, and the type that it spawns is bullet. This string literal that we use here is going to affect how you call the spawn method on the game world, which we'll come back to in a few moments. But this and that, they don't have to be the same. They can be different. In fact, this method name doesn't even matter if you're not going to use the factory directly. And again, I'm going to explain what that means in a few moments. Just going to copy this, because this will be very similar for a new enemy and enemy. So again, we call entities builder from data type is going to be now enemy. And the node is going to be new rectangle 40 width and height, so it's a square, and we'll set the color to red. Once we've created our factory, we also want to specify that this factory class to be added as an entity factory. So this is one of the new things in FXGL 0.3, where we use annotations metaprogramming to simplify the code. And that should be enough. Well, I suppose we could add with new collidable before we forget. This basically means that these two objects can collide. Otherwise, the collision detection will ignore these objects or these entities. We can now override initialize game, and if your ID your ID shows what things you can override, you can see that there are other initializing methods, so like UI, physics, and input. You're no longer it's no longer compulsory to override them, but it is still important to keep the code related to user interface in a UI method so that other developers can easily find the code that deals with the user interface. And in a similar way, other code as well, like physics. So in initialize game, we are going to create enemies. So we said that our enemies are going to be spawned at random positions. And let's give it an interval of 1 second. Anything to do with intervals, you call getMasterTimer, and you can run something at interval. And that something is the code that you pass in. So the code between these curly braces is going to run at the interval of 1 second. And that code is going to be spawn enemy. From now on, you can no longer, well, you can actually still use the factory. So you can use the previous programming model for FXGL, but the new one is more concise. And instead of calling anything from here, you get reference to the game world and simply call spawn. And the string literal that you pass here as a parameter is exactly the same as the one that you want to spawn, as the object you want to spawn. So if you want to spawn an enemy, you will need to pass in the same string, like this. And we can also specify the X and the Y, where to spawn this entity. Which we're going to use math.random. That should give us start and end, say 0, get width -40, and the same for the height. Actually, we probably want to spawn at the slightly higher than the middle. So that should give us the middle. We can now test the code and see if it actually does what it's supposed to do. Yes, so it's spawning enemies at random locations every 1 second. We also probably want to limit the number of enemies to spawn. And in order to do that, we're going to keep track of the number of enemies currently in the game. And in the new version of FXGL, we can utilize game variables, which is a variable scoped it's almost like a global variable, but it has a scope of the game instance. So it's accessible from anywhere in the game. And we're going to create a variable called enemies with the initial value of 0. If you pass an integer, it will be initialized as an integer. If you pass a double, it will be initialized as a double. So currently we want an integer, and by default there will be 0 enemies. As soon as we spawn an enemy, we are going to increase the counter, which is that variable, by 1. This is where we initialize the variables, and in order to access or modify the variables, we use gameState. And we need to increment enemies by 1. I tend to put plus or minus sign here, which is essentially just a syntactic sugar. We can also query number of enemies now by saying get gameState, get int enemies. Finally, we can check if number of enemies is less than, say, 5. Then do this. We can now check this and see if there will be more than 5 enemies spawned. There shouldn't be. So we have 5 enemies, and this is the maximum. We can now spawn, create bullets, because we want to be able to kill and destroy the enemies. And in order to do that, we will need to take some user input from, to take some input from the user. We can do this in initialize input. We first obtain a reference to the input service by calling get input. Then we can add a new action, which is new user action, and we're going to override it on action begin method. On action begin is called once per input trigger, and input trigger can be either a mouse button press or keyboard press, so key press. We're going to call it shoot, and we're going to bind that action to actually I'm going to bind it to mouse button. So this is the left click. And on action begin, we're going to shoot. We're going to spawn a bullet, and we're going to spawn it at the mouse position. Actually, we're going to spawn it at mouse position X, but the Y value is going to be height minus, say, 10. So it will always spawn from the bottom, the bullet, but its X value is going to be based on where the cursor is. So these are the bullets that you can see at the very bottom. We now want to be able to control the bullets, and there's already a built-in class called projectile control. So if we go back to our bullet creation method and add a new control called projectile, it takes a direction, and direction in our case is 0 in X direction and Y in Y direction. Actually 1 in Y direction. So it's new point 0, and in fact it's -1 because 1 is the positive y-axis goes down in graphics frameworks and also in FXGL, which means to move up we need to use a negative value. As for speed, let's put value of 200 and see if that is suitable. So as you can see, the bullet has been rotated correctly based on its direction, because by default it was spawning facing right. Can make it slightly faster by putting 300. Finally, we want the bullets to collide with our enemies. Although they are marked as collidable, there isn't actually a collision handler for them, and therefore they are ignored by the physics world. So we're going to override init physics, and we're going to create, well, first of all, we'll obtain a reference to the physics world. And again, we call getPhysicsWorld to obtain the reference. Then we're going to add a collision handler. And we want to override a method onCollisionBegin, which is fired once when the collision starts happening. In the constructor of collision handler, we specify the two entity types that we're interested in. Currently it's bullet and enemy. So if you pass in them in this, if you pass these types in this order, like bullet and enemy, then these two entities are also going to be in the same order. As soon as they collide, we want the bullet to be destroyed, as well as enemy be destroyed. And if you remember, we use this variable to keep track of the number of enemies in the world. So once the enemy is destroyed, we might as well reduce that value by 1. So instead of passing +1, I'm going to pass -1. So now when we shoot, our bullet hits the enemy and both entities are destroyed. And our timer still keeps track of number of enemies and only spawns 5 at maximum. So this is pretty much it. We've done all we needed to do. We created a very simple game that incorporates quite a lot of things. We've learned how to use input, how to use game variables, also the new architecture for FXGL games, which is to use annotations and entity factories in order to spawn the entities. You can still keep doing what you were doing with FXGL, for example, 0.29. All of that stuff is still valid, although some packages have been renamed. But the new model is more concise, and therefore you're likely to produce better code and less error-prone code, which is something that we always strive to do. There will be several links in the description pointing to various resources about FXGL, also the wiki for FXGL, and a few other tutorials. But for this tutorial, we've completed the goal, and we now have a simple game where we can shoot enemies and they get destroyed. So thanks for watching.